students. In this class, we will learn how we can solve these kind of trigonometric problems. So, there are two problems. In the first problem, we have given sec theta plus tan theta equals to p, and we have to prove p square minus 1 whole divided by p square plus 1 equals to sin theta. And in the second problem, we have to prove tan a whole divided by 1 minus cot a plus cot a whole divided by 1 minus tan a is equals to 1 plus tan a plus cot a or 1 plus sec a into cosec a. Okay, so now follow the class how we can solve this kind of trigonometric identity problem. Solution 1. Here we have sec theta plus tan theta equals to p. So therefore, we can write the reciprocal form of sec theta, that is 1 by cos theta, and tan theta in terms of sin theta and cos theta, that is tan theta equals to sin theta by cos theta. Then we can add these two. That LCM is cos theta, and in the numerator there will be 1 plus sin theta. Okay. Now we have to prove p square minus 1 whole divided by p square plus 1 equals to sin theta. That means we have to convert this cos theta in terms of sin theta. We know sin square theta plus cos square theta equals to 1. Since this, therefore, cos square theta is equals to 1 minus sin square theta. So, to make this cos square theta, we have to square on both sides. So, squaring both sides, we get 1 plus sin theta whole divided by cos theta whole square equals to p square. So, squaring both sides. So, from this we can write 1 plus sin theta whole square whole divided by cos square theta equals to p square. So, by the relation cos square theta equals to 1 minus sin square theta, we get 1 plus sin theta whole square whole divided by 1 minus sin square theta equals to p square. So this implies 1 plus sin theta whole square whole divided by 1 plus sin theta into 1 minus sin theta. By using the algebraic identity, a square minus b square is equals to a plus b into a minus b. Okay. Then we can cancel this 1 plus sin theta from the numerator and denominator. So thus we get 1 plus sin theta whole divided by 1 minus sin theta is equals to p square. Now we can apply componendo dividendo. Already we know what is componendo dividendo, which is a ratio proportion relation. In our previous video, we learned all of the ratio proportion relations. So now nothing is in the present in the denominator. P square means 1 is present. So we can write p square as p square by 1. Since a by b equals to if a by b is equals to c by d, then by componendo dividendo we get a plus b whole divided by a minus b is equals to c plus d whole divided by c minus d. Now by following this relation we have 1 plus sine theta plus 1 minus sine theta whole divided by 1 plus sine theta minus of 1 minus sine theta is equals to p square plus 1 whole divided by p square minus 1. So after removing all the brackets we get 1 plus sine theta plus 1 minus sine theta whole divided by 1 plus sine theta minus 1 plus sine theta is equals to p square plus 1 whole divided by p square minus 1. By cancelling sine theta and 1 from numerator and denominator we get 2 by 2 sine theta is equals to p square minus 1 p square plus 1 whole divided by p square minus 1. Now cancelling 2 from numerator and denominator we get 1 by sine theta is equals to p square plus 1 whole divided by p square minus 1. Now to find sine theta we have to use another ratio proportion relation which already we know, that is inverted. If a by b is equals to c by d, then by invert endo we get b by a is equals to d by c. So by applying this invert endo we have sine theta is equals to p square minus 1 whole divided by p square plus 1. This implies p square minus 1 whole divided by p square plus 1 equals to sine theta. Proved. So this is one of the procedure by which we can prove this relation from this given relation. So there are so many different procedures which we can apply to solve this kind of problem. So this is one of the procedure. Why we use this procedure? We use this procedure to represent all of you how we can apply these trigonometric identities as well as ratio proportion relations, algebraic identities in this problem. Okay. So in our next class we will solve the problem number 2.